This is really the only way to do it for a 3 by 3. So we'll do it, but it's a lot of work. So for this next example, we're going to look at finding the inverse of a 3 by 3 matrix. The only way to find the inverse of a 3 by 3 matrix is to put the 3 by 3 matrix right next to the identity matrix in one big augmented matrix. So we will take our original matrix, which is -2, 2, 4, -3, 4, 5, 1, 0, 2, and we will put that in a big matrix with a line next to it so that we can separate it from the other side, which is going to have our identity matrix. Remember, the identity matrix has 1s along the main diagonal and 0s everywhere else. So the goal is to take that entire left-hand side here and turn it into the identity matrix. So let's see how this goes. We need to use row operations to do this. So we'll start with one element at a time to focus on, just like before. So we'll start with, first of all, this -2, and the identity matrix is a 1 there. So how do we turn that into a 1? Again, this should remind you a lot of a reduced row echelon form. So to get that -2 to turn into a 1, well, we took that entire first row and divided it by a -2. So the -2 divided by a -2 gave you a 1. The 2 divided by a -2 gives you a -1. The 4 divided by the -2 gives you a -2. And on the other side, where we actually have the identity matrix to start, 1 divided by a -2 gives you a 1/2, and the 2 zeros divided by a -2 won't change, so the rest of the line will stay the same because 0 divided by anything will give you 0. Now we've got one of the ones we need for an identity matrix. Now we'd work on getting zeros everywhere below it. So we'd work on turning the -3 and the 1 here into zeros. Well, so one at a time, if I worked on getting the 1 to turn into a 0 first, well, we would take the row 1 and multiply the entire thing by a -1 and add it to row 3. And this is the result. So -1 times row 1 would give us, well, in the first term, -1 added to your row 3, which already has a 1, would give you your 0 that you need. But you have to do this for the entire row. -1 times row 1 with the second entry gives you 1. Added to the 0 you have gives you a +1. Keep on going. -2 times the -1 gives you a +2. But you already have a 2. So added to the 2 you already have gives you 4. Now -1 times the -1/2 gives you a 1/2. Added to the 0 gives you a +1/2. Keep on going. -1 times 0 is 0. Added to 0 is still 0. -1 times 0 is 0. Added to 1 is now going to stay as a 1. So we got 1 0 in our identity for our first column. We have to go after getting the second 0 here where this -3 is. To do that, you're going to multiply row 1 times 3 and add it to row 2. So 3 times 1 gives you 3. Added to your -3 will give you 0. 3 times -1 will give you -3. Added to 4 gives you a +1. -2 times 3 gives you -6. Added to 5 is -1. -1/2 times 3 gives you negative 3 halves. Added to 0 is still negative 3 halves. 3 times 0 is 0. Added to 1, though, is still going to be 1. 0 times 3 is 0. Added to 0 is still 0. So notice that does get us somewhere. It does get us, let's see, the entire first column of being correct as an identity. Now, inadvertently, what also happened is I do have my next 1. Yay. So I'm pretty close to getting there. I've got my first column and I've got the next 1, which is the goal when you're doing reduced row echelon form. So let's go after getting the next 0 below it. So how do we get a 0 below it? Well, we're going to do negative 1 times your row 2 added to row 3. So negative 1 times 0 added to 0 is still 0. Negative 1 times 1 added to 1 will give us 0 like we wanted. Again, negative 1 times negative 1 will give us 1. Added to 4 gives us 5. Negative 1 times 3 halves is 3 halves. Added to the 1 half gives us 4 halves, which is 2. Negative 1 times 1 gives us negative 1. Added to 0 is negative 1. Negative 1 times 0 is 0. Added to 1 is still 1. So we're getting there. We now have the entire first column. And almost the second column, we got a 1 and a 0. We still have to get our last 1 to make up the main diagonal of our matrix. So I need to get that 5 to turn into a 1. How do I do that in row 3? We're going to divide all of row 3 by a 5. So, well, first term, 0 divided by 5 is 0. 0 divided by 5 is still 0. 5 divided by 5 is 1. 2 divided by 5 is 5 halves. Negative 1 divided by 5 is negative 1/5. 1 divided by 5 is 1/5. So bad thing is we are starting to get some fractions, but it's okay. Keep on going. Now I've got my main diagonal as 1s. Look at that. We have our main diagonal as 1s, and we do have 0s below it. Now all we have to do is make sure that the triangle above it turns into 0s, and we've actually got one of them is okay already. So now we're actually just worried about the other 2 entries above the line of 1s need to turn into 0s. So one at a time. It doesn't matter which you go after first. So I'm going to go after this negative 1 and turning that into a 0 first. How am I going to do that? I am going to do, let's see, we're going to take row 2 and just go ahead and add it to row 1. So we're going to take row 2 and just go ahead and add it to row 1. So 0 added to 1 is 1. 1 added to negative 1 is 0. 0 added to negative 2 is negative 2. Negative 9/10 added to negative 1/2 is going to give us actually negative 14/10, but that reduces to negative 7/5. And then we've also got 4/5 added to 0, which is 4/5. 1/5 added to 0, which is 1/5. So we're getting there. We have one last entry that we're worried about, and that's this negative 2 and how to turn that into a 0. So let's work on that. We'll do that by doing 2 times row 3 added to row 1. So 2 times row